Hello.
Hello.
Hi, Srinivas.
Hi, Rita. Good evening. You can start the recording.
Yeah. Hmm.
Start. You're able to see my screen?
Hmm.
These are
Able
the
to see.
topics we discussed during the last class. So, do you have doubt? Any topic?
No.
Yes. You're able to practice on all those things.
Yeah.
Thread joining. So, thread joining basically, if we have a method called join method, which waits for thread today, means it causes the currently running thread to stop execution until that thread it joins with complete its task. Means like when you're working with the multiple threads.
Hmm.
Okay. Generally, when you start both the threads, what happens usually? Both the threads are going to execute the run method logic at the same time. They're
Same time
working
parallel.
parallel, right? There
Hmm.
are certain cases that I do not want to execute parallelly. Those threads are meant for running and giving the feature to run them parallelly, but there are certain cases that I want to make a dependency. So I would like to complete the first guy first and then the second guy. So what I have to do, I have to join both of them,
Okay.
right? So suppose I'll be joining them. So when I join, so what happens? So one the first guy completes and then only second guy comes into picture, like whatever the expression.
Okay, we can avoid parallel running. Okay.
Yes. So not to
Hmm.
avoid. So basically, if there is any requirement as such, if
Okay.
we
Hmm.
because if you have some dependency, so until that completes the dependency, you do not go with that, right? So let me
Yeah.
come. So you need to create a dependency in such a way that you are going to join with some thread. So that thread is complete, then you are going to kick your thread automatically.
Okay.
Might take 1 day, it might 2 days, whatever. So as and when it completes, immediately your thing starts.
Hmm.
Got it? The join is a method which is going to help us in achieving that function.
Okay. Hmm.
So this is the run function which is going to help us in running for printing 1 to 5 numbers, right? So you know the
Okay.
difference, like what happens when you make a sleep method.
Hmm.
1, 1, 2, 2, 2, like that it comes, right?
Hmm. Hmm.
So this is your basic thread. Now I'll be creating multiple instances for your thread. So my T1 is one thread. So for that, like I'll be joining now. T1 dot start. I said T1 dot start. T1 dot start. There will be like one more. So you are going to join with T1 threads. So you are joining with T1 now. So what are the other two threads? T2 dot start. T3 dot start. So here, what we did here, so we have all three threads to run the same functionality. But I do not. I wanted to complete T1 first, and then I'll be doing the T2 and T3 immediately. So as and when I start T1, I am joining T1. So first it's complete history, then these two will start execution.
Okay, okay.
1, 2, 3, 4, 5, and then 1, 1, 2, 2, 3, 3, 0, 1. Got it? Run in
One by
parallel.
one.
So that's where like if you're not giving threaded slip, this will also gives you like 1, 2, 3, 4, 1, 2, 3, 4, 5, right? That's what we have seen earlier. Because we have started given a join, so these two has to wait until this guy completes.
Yeah, first it, okay.
That's
First
where
need.
the joining is going to help us.
Okay, okay.
Here now the next one is called the priority select. So now here we have given the dependencies, right? In the same way, we do have some concept called priority. So there are certain cases that though you have multiple threads, I would like to give a more priority to another thread, right? It happens, right? So we wanted to give a priority so that that guy given a more consideration. So priorities can be represented with a number like 1 to 10. Means you can give priority value between like 1 to 10, or else you can have most commonly three constants are given. Either you can give 1 to 10, or 1 to 10, or else you can say mean. This is equal to 1, this is equal to 5. 10. That means valid values are 1 to 10 if you want to give the value. Otherwise,
Okay.
if you want to use a constant, thread itself has a constant called min priority, norm priority. Norm is nothing, normal priority and max priority. So instead of giving 1, 5, 10, so if you want to give 1, either you can give 1 or you can use this one. If you want to give 5, either you can give 5 or you can use this one. For 10, that means out of these 1 to 10, for 3 values, they are given 3 different constants,
Okay.
top, bottom, and middle. So for 2, 3, 4, and 6, 7, 8, they have not given any constants. We just mention the number.
Okay.
Okay. So in most cases, thread scheduler is going to schedule the thread according to the priority that we are given here. But it's not guaranteed because it all depends on the JVM specification that is scheduling. It's only like the request that we can make that I want this thread to be given a more priority, I want that thread to be given a more priority. Okay.
Okay.
So default priority for any thread is 5.
Okay. Default priority means normal priority.
Exactly, it's normal, it's the medium one.
Okay. Minimum, maximum, medium. Okay.
Okay. So instead of medium, so we say that it's priority, normal priority.
Okay.
From
Okay.
the constant perspective, from the reading perspective, as I said, it's correct, it's a medium one.
Okay.
Got it?
Okay.
So we can change the priority at any point of time, so we can apply the priority level. Okay, so I'll show you the usage directly. I just created 2 threads. So I would like to know that what is the priority. So in run method, in case you want to know the priority, simply you can ask for thread. Right? Yesterday you have seen this method, right?
Yes.
To set
Get
the
name.
logic accordingly like that.
Hmm.
So what we are doing here,
Default name it gave.
we just created 2 threads and we have just started. So we in the run method, we would like to see that what is the thread name and what is its priority. So thread 0 and thread 1 is the names. Obviously,
Thread.
priority is the default one, 5, right?
Okay.
So yes. So now, if you want to give any priority value for it, you can give it. So I can say t1 dot and priority is a method. So priority, see that constants are given max, min, or you can give any value, or you can give a number like this.
Oh, instead of that new priority, okay.
So
Name.
thread dot norm is the default, right? I'll give min priority, right? So for T1 thread it will be 10, and for T2 thread it will be 1.
One. Okay, set priority. Okay.
The method is equal to the same way we have seen set name, right? Name.
Set name, yes.
Yeah, in the same way we can even set the priority. We have a separate priority method for setting the priority value.
Okay.
So here the expression is given changed accordingly, right? Whichever is the expression. Suppose for T2 I given more priority, for T1 I given less priority. Accordingly, it just gives the instruction accordingly. Got it? It's only the priority instruction. Clear the priority perspective?
Okay. Yeah.
The next one is the Daemon thread. Have you ever heard this word, the Daemon?
So if thread priority, we are giving the numbers. I mean, minimum priority, maximum. By that, if once we assign the priority, by that it runs.
Yeah, based on the
Depending on the.
priority value it's going to be it's invoked. So once it's just, as I said, it's just a instruction that you can give to the operating system. Their JVM. The JVM is
Okay.
going to take care, like it's all depends on the operating system internal availability, and it gets
Okay.
the functionality. Okay, so resources ability based.
Okay. Based on the priority, it invokes that method.
Exactly.
Okay.
Got it? The daemon.
So thread priorities. Okay. Demon thread.
Daemon thread. Basically, daemon thread are like special thread which stops automatically as soon as the main thread terminates. JVM doesn't wait for any daemon thread to finish before executing. Let's say you are working with them multiple threads. Okay,
Okay.
so daemon. So if it is a daemon thread, it is a kind of like a special thread which stops automatically as soon as the main thread terminates. In generally, even if the main thread is terminated, your child thread still continue because it has something to do. But here you are making a dependence that if that guy completes his task, so like I would like to close my activities, everything. So you need to make your thread as demand, means you are going to make a dependency with that main thread. So as and when the main thread is completed, you are going to close it right away. Got it? The dependency. If the main logic is completed, why should I still continue? So I can I can exit from my logic, right? If you do that, so you need to mark your thread as daemon. So you are daemon to the main thread. So as
Okay.
that guy is done, so even though your task is not completed, still you'll be exiting. Got it?
Okay, got it.
So that's
Understood.
the most common interview question with the Daemon.
Okay.
What is a daemon thread or how to create a daemon thread? Anything related to daemon.
Okay.
Obviously thread threads and also thread naming as well. But when they are asking for threads, you can expect a question about the joinings and the daemons.
Hmm. The type.
Okay, sorry. I was about to type, so I thought it's telling something else.
Okay.
While true means what happens? It's an infinite loop, right?
Okay. Hmm.
We are
Yes.
seeing when we are working with the files. First, I'll show you without daemon how it behaves. Then, on top of that, I'll apply a daemon setting.
Okay.
So what we did, we have created a separate thread, right? So
Hmm.
when it's runnable, there is a run method. Inside that infinite loop, which continuously it prints this, sleeps for some time, and continuously prints this and sleeps for some time. That's all right. So
Hmm.
this is going to be like infinite kind of loop kind of thing, right? Because
Hmm.
they are given one while true. If you are not given while true, this will print only once. Next
Hmm.
one, you have this is one thread, and now you have created one more thread extending my thread, right?
Hmm.
Also
Hmm.
extend a thread. So there is a run main method inside that. You are creating a thread object
Hmm.
by passing this interface, right? Yesterday we have seen, right? If you
Yes.
implement runnable interface, you cannot start directly. You have to wrap it with a thread. So I just
Okay.
wrapped it yesterday. I think today is thread test. Where is runnable? Yeah, runnable test.
Runnable.
So how you have run this one? So you created a thread. For that you
Thread.
pass run, right? Then only I got a start method.
Yeah. Yeah. Yeah.
Same thing.
It's doing that.
So
Okay.
I'm create. Suppose if I create instance for it, I cannot run, right? So I have to wrap it with
Yes.
thread.
You
So that
thread.
then only I
Yes.
can start.
Yes.
So
Hmm.
when I click on start, this loop
So
will
you did
begin
all that
counting.
in one line, right?
Yes. in one
Okay.
line.
Save in one line. Okay, that's
So
very simple.
generally, so this is kind of like anonymous creation.
Okay.
Yesterday you have seen it, not maybe 2 days back. In the
Yeah,
class.
I saw, but
This kind of
you wrote and again you just made it as two lines for
yes, exactly. Yeah. That
yeah.
usually in real time we go for this kind of thing. The reason is
Okay.
if you do that way, you're passing R here. Once you passed here, are we using R anywhere? No, right?
No.
Unnecessary, the block is named with some name, right? So what you can do on the fly, you can create and you can assign that to here. Like I said,
Okay.
new runnable test directly.
Okay.
So if the research is not required for the later on,
Hmm.
you can just make it an on the fly creation. This
Okay.
kind of initialization is called the anonymous instance creation.
Hmm.
So
Okay.
as and when you click invoke a start method, this logic gets executed, right?
Hmm.
Now this your program is also thread if you observe because you have extended thread, right? You
Hmm.
are executing the main logic and you are doing something in the main method. So you are
Hmm.
also one thread you are doing there also it's happening one thing. Now you can see whatever.
Yes.
Done with main thread I said. Still it's continuing, right? Child thread.
Yeah. Yeah.
So you're done with main program. Why to continue child one, right?
Hmm.
That's a quite common requirement.
Okay.
So let me repeat the statement with the daemon thread. In generally, when you're working with multiple threads, like there are certain cases that there is a parent thread and there is a child thread. Once the
Yes.
parent is completed, why should we go for still the child thread,
Hmm.
right?
Okay. Yes.
So obviously we would like to close it ourselves. That's with it. So what you need to do, you need to mark your thread as a daemon thread. That means you are kind of a daemon, which you are depending on the completion of the main thread.
So once we are done with the parent thread, so no need to go.
Once you are done with the parent thread, so child, so that means let's say main thread is printing 1 to 10 numbers. Okay, child thread is printing 1 to 1000 numbers. So
Hmm.
generally, when you start both the threads, main thread prints 1 to 10 and child is going to print after 10 continues till 1000, right? But
Yes.
I do
Yes.
not want to happen that. As and when main thread completes 10, so be it like the child is willing to print 1000 or whatever, so I would like to stop after 10
Okay.
because the parent is done, so why should you still continue? So I would
Hmm.
like to close it.
Hmm.
So that means you need to mark your child thread as
Hmm.
daemon thread. We are going
Okay.
to daemon. Okay,
Okay.
we are going to here
It's still
continue the main method processing daemon. So here it said done with main method main thread.
method.
So we are continuing. So forcefully I break my execution.
Hmm.
So if you want to avoid this, I can say that that's all. You are
Okay.
marking your thread as daemon. Now you are becoming a like daemon kind of a behavior. So as and when main completes, irrespective of the number of executions that you have made till that time, you are going to stop processing daemon thread, continuous main thread. As and when the main thread completes, see that just stop the execution, right?
Okay.
The main guy completed, so when you are done with this, if you are not
Hmm.
starting this one, it
Hmm.
will be like infinite loop because the logic is written in such a way. See that it's going to be forever.
Yes. Yes. Just we kept that in infinite loop, right?
Yeah, infinite loop, right? It continues. So there are certain cases that you don't know when to break a certain condition, right? But you would
Hmm.
like to make a dependency with something.
Hmm.
So that's how you mark yourself as daemon. You are daemon to the thread.
Hmm.
Got it?
Understood.
So here definitely you need to have the multiple threads. One thread is performing something in the infinite loop. and another thread is performing the main logic, and
Main logic. Okay, thread.
logic is simple. Only thing like we are making a relationship dependency. We are making a dependency here with this one. If that guy is completed, so better you close yourself. Like why to proceed further? That's why we are giving a instruction to this guy.
Okay. So we gave T dot set demon true.
Yes, means you are Daemon. So you are Daemon. So whatever the main one is completed, you need to complete you need to stop yourself forcefully.
Okay. Okay, I thought that we need to give the child name.
Hmm. See, this is the child thread only, right?
Child.
What is T child thread? What is
Yeah, T is the
Daemon
child
thread?
thread.
This is
Okay.
the child thread. So this is happening infinitely. So I would like to stop this guy as and when my main thread completes.
Okay. Okay.
Let me zoom it.
No, when it goes to the main thread, just it comes to thread T, new thread, new demon thread. It goes to the top demon thread.
Yeah, it creates an instance for it, and it will wrap it with T. Then after
Uh,
T dot start, it's going to execute this logic.
uh,
So this is your main thread logic. You're doing
mm,
something here, or everything is you're done. You said like
mm,
I'm done with it. Even
mm.
though you're done with it, because this guy is an infinite loop, your child thread. This is your child thread to this thread. So this is your main thread, and this is your child thread.
Oh, that's what I'm getting confused. That's it.
Okay, okay, names are like both are given that this one. This
No,
child thread.
okay, this is the main thread, this is the parent, main thread, and the top one is the child thread.
Okay.
Okay.
Because right, we are using this guy in this one. We are not using this guy in there,
Oh,
right?
okay, okay, okay.
You are the owner. So that is like the borrowed one.
Okay,
Okay.
okay, okay. This extends thread. Yes, this is the main. Yeah. Yes, now I got understood.
Okay. Deadlock and threats. Quite common question with respect to interviews. So deadlock, generally, what is deadlock? Not only Java, in general.
Mm, no, no,
No?
no.
So two guys are there, suppose. So
Mm,
one guy is waiting for the other guy at one location. The other guy
mm,
is waiting for the first guy at some other location. What happens? Will they come to an end?
no.
So both are waiting for each other ultimately. So
Okay.
I'm waiting for that guy and he's waiting for myself.
So you can't.
Never come to an end.
Like,
It will be
yeah.
deadlock stage.
Yes, they both will be waiting for like that.
This way the deadlock is in simple terms. Okay.
Okay.
So deadlock is a quite common thing. It happens. So it's a part of like multi-threading programming. It can occur in a situation when thread is waiting for an object lock and that is acquired by some other thread. And second thread is waiting for the object lock that is acquired by the first thread. Since both threads are waiting for each other to release the lock, the condition is called the deadlock.
Both threads are waiting for each other to release the locks.
Lock,
Okay. Hmm.
right?
So,
That's where the situation comes in the picture. Means here we are having dependency mutually. Until
mm,
you complete, I cannot complete my work. So
mm.
if I need to complete I task, you need to complete your task. So there is
Mm.
a kind of a contradictory kind of statement. What you so first I'll show you the program how to make a deadlock situation. Means how to see the deadlock situation,
Mm.
and then
Okay.
we just change the coding order with a small tree to avoid the deadlock. When,
Okay. Okay.
whenever we are working in a programs like especially threads, so the most common one, the deadlocks are quite common. So developer has to take care about writing the program to avoid the deadlock.
So, okay. Okay. Understood.
When I say avoiding deadlock means, so you need to do things in a following order. So if one is waiting for two, two is waiting for one. So you
Mm.
need to do that. So we complete one and complete two and complete two or complete one. There is a order
Mm.
that has to be followed.
Mm.
You will never end up with the deadlock situation.
Mm. Mm.
Mhm.
Mm.
Deadlock is not specific to Java, it's a general terminology, any programming language. Even you might see this word, especially in the databases, most other. Means one guy is updating a record and the other guy is trying to perform something else with that record.
Okay.
It happens lock, right? That record is locked, but not for doing something else.
Okay.
Uh, what is this kind of coding? You remember anonymous? Anonymous in our class, right?
Yes, yes.
Instead of extending a thread, what I'm doing, I'm creating a thread object anonymously.
Okay. Yeah, we discussed that.
So I'm going to use the synchronized keyword here. So synchronized keyword means only one person can do things at the same time. So come back to
Okay.
this point once again. So first now I'll be doing an example. I created two objects. Right? Thread T1 anonymously I'm creating a instance. Instead of creating a new thread object, I'm creating on the fly. Okay. There is a run method. Said that synchronized is a keyword. If you give this keyword, whatever the logic which you have coded inside that is going to be executed by only one thread at a time.
It will.
Only one thread will execute the logic at a time.
Okay, one thread. Okay.
If you have two threads, T1 that start and T2 start, what happens? Both the thread comes here, both the thread will execute, right? Both. I do not want both guys to execute. I want one after the other. So first guy enters inside this, and if he is doing something here, let's assume that this internal logic is taking 1 hour. Until that 1 hour, so second guy has to wait here.
Oh, just now we discussed about some thread that it can also help in doing that. I mean, one
Join.
after other.
Join is a dependency.
Okay, join. Yes, join. Join is a
Dependency. Until you are done with you are done with preparing food, we cannot eat, right?
yeah.
Dependency. But here I'm not talking about the dependency.
Okay.
So here until the first, so whatever the logic here, I want only one person to continue at the same time. There
Oh,
you have created a dependency with thread T1, right? Until T1 complete, T2 and T3 cannot execute. But here, I'm not talking about the particular thread. I'm having multiple thread instances for my thread. Let's say I created 3 threads. So when I say start, all comes into execution, right?
Yeah.
In the first execution, I'm okay with it, but I want to do it only one guy at a time.
Okay.
I want
Okay.
the logic to be executed only one guy at a time.
Okay.
There it is that I want this guy comes first and that guy done with his task, and then we'll proceed further with the execution. Clear or any confusion?
Okay. 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 I'm clear.
Okay. There you are preparing a food and some until that no one else has to. Here in this case, let's assume that we have like multiple guys are there, and whoever comes first, he has to start cooking.
Okay. Yeah.
So got it?
Okay.
So in your run method, the synchronized keyword, which is going to help us in accepting only one resource at a time, means one thread at a time. But entered inside this other thread, even though he is ready, he is willing to continue his task, he has to wait here until he completes his task. Okay. So inside message what you are saying, thread T1 locked object 1. So when I say synchronized and whatever the object you passed, so it create a lock. Means he's locking this guy. So that nobody enters inside. So he's locking the door here. So 31 locked object 1.
Okay. Okay.
After that, he is sleeping for a certain time. Then,
So to lock that object, we use synchronized object 1.
Synchronized keyword.
Okay. Keyword. Okay.
Synchronized key 1, which inside that he is locking one more object.
Okay.
Got it? Thread 1 locked object. So what I am doing here, I am locking object 1 and then object 2. This is the order I followed. Now I'm just exactly copying it. I'll change to T2, so I can say now thread 2, right? Thread 2, right?
Yeah, you can. Object 2.
Object 2 and object 1. Remember that earlier object 1 and object 2. Now it says object 2 and object 1.
Object 1, yes.
Right? So we are almost close to the program. So now what I am going to do? Now you have to tell me what happens now. I'm going to run the program. T1, T2 both started. Thread 1 locked object 1, right?
Yeah.
Thread 1 locked object 1 is sleeping for a certain time. Okay. By the time thread 2 also started, thread 2 locked object 2, right? It is also sleeping for some time.
Okay.
To get into the details, so here keep for hours or minutes or days. This will stop here. Program will not execute.
So here we gave sleep method, I mean for 2 seconds like that in try block.
200 milliseconds is already completed.
Okay, after that does it so it does not goes to another object, I mean synchronized object 2.
It is attempting, so it is trying to lock the object 2. Okay, but the object 2 is already locked by this guy.
Okay, no, my doubt is when it is going to the try block, just it is getting the answer like just leave for some time.
Okay.
So automatically does it not comes to the
You're taking you to rest, take a rest. When you are asked to take a rest, you're going to take a rest. You're not going to do any other task, right?
But
like sleeping method.
Okay. Okay. So it takes. I'm still getting that. Okay. Okay. If it says that take rest for some time, so it is exiting from the whole.
So still you're not came out. You entered set. So here 2 guys are there. Thread 1 and thread 2, right?
Yes, thread 1 and thread 2.
You entered, printed this one, and he's sleeping for some time. By the time this guy is sleeping, what if
Yes.
prepared guy is also entering
But,
this one? He's sleeping for
so
okay.
so once it is sleeping, does not we come to this system.out.println thread one locked by object two?
Still you are sleeping. That means you are waiting here itself. You will not come here.
Oh, that's what my question. Okay,
You are still here. You are
okay,
sleeping here. You are there here. Nothing else. You are at the line 21. There you are
okay.
like a tortoise. You are sleeping there. So there is
Once we're sleeping, we will exit from that method and
you will not.
we'll come out from
Let's say if you exit for method, then when you are going to come back?
after
As
running
per
the second another method.
another method is that is different, right? So as per the life cycle, when you started thread, it's a new state. After that, it will be running. Once
Mm.
running, you can go for sleep and come back to running. Once you and you're done with the program.
Okay.
That's for that lesson. So when you are sleeping, you are there at line, the same line. Still, you are waiting for it. You are sleeping.
Okay.
Once you are done with 200 milliseconds, then you feel that you moving slowly, moving. You came here. Okay. Now you
Okay.
are trying to lock the object too.
Mm.
Okay, but
But already,
unfortunately, this guy is already locked.
yes, object already.
You
Mm.
cannot enter inside. You keep on trying. It will be like infinite loop internally. You keep
Okay.
on trying for this guy, but this guy
Mm.
is already locked, and he is waiting for this something else like object one. These guys keep on trying for give me an object one. Who is going to give? This guy has to.
Mm. Yeah.
If this guy has to give means he has to complete this task. So who is going to give this one the object to? This guy is hold
Okay. Okay. So we need to release that. Okay.
So problem is the order of picking the things. Now let me break the program. Solution is very simple. Just change here 1 and 2, right? In the same way I'm following 1 and 2. That's all.
Mm.
This ends the matter. Right? Thread 1 is done 1 and 2 and thread 1 and 2. So what's main intention here is this guy is holding something and then holding this one. So the other thread is also following the same thing, means it will never come to any kind of a conflict at all.
Okay.
Understood or any confusion?
No, understood.
Right? So in general, if you know what, if you understood, if you are clear with the threading, like the deadlock, then it's going to be the same thing anywhere.
Okay.
So now you are clear about the synchronized keyword also, right?
Yeah. To lock that, we use that.
Yes. To log that, like when you use the synchronized keyword in generally, you cannot execute the logic inside. Like means only one guy can execute the logic inside that method or the block.
So once we'll go for the program, so we need to release that lock, right?
Which one? This one?
Yeah.
Once you are done with this one, obviously you'll come out of this block. Once you are done, come out of this one, everything will be released. Because this guy is released, then only this guy is able to access it. So if you see the console, thread 1 logged object 1, thread 1 logged object 2.
Object to.
Once these two statements are completed means he is done with thread 1 execution. So obviously by the time he completes, he released everything.
Yeah. Okay.
Because if this guy is released, this guy is able to hold it.
Oh, okay.
If he is throwing, then he is catching. If he is not throwing, obviously this guy cannot. Okay.
Okay, we removed that synchronized at top. Okay.
We are not remove synchronized, only the
Okay.
order we have changed.
Thread one.
Object 1 and object 2 right earlier.
Okay.
Only
Okay.
object
You
2 and
changed that
object
object.
1.
Okay.
No, just change the order for this one. That
Yeah.
means
You before you change that. Yes. I
the
saw.
ordering is important to avoid the locking.
Okay.
Okay, that's the main point.
Okay. Ordering is very important for locking. Okay. Now it's clear.
The garbage collection.
Okay.
You might have heard this word maybe in the 4th class.
Yeah, garbage collector.
right?
Yes.
Do you remember something?
Yeah, I do remember.
Okay. So garbage collection is not specific to Java. It's a
Hmm.
general like operating system specific. In, so I'll just give you the what happens in the background. So it's a
Hmm.
principal method of detecting and reclaiming the free nodes. That means nodes no longer in use remains allocated
Hmm.
and undetected until all the available storage has been allocated. The subsequent request for allocation cannot be satisfied until the nodes that are have been allocated but are no longer in use are recovered. When the request is made for additional nodes and there are no available nodes, system routine garbage collector is going to be called from the definition. Now I'll tell you the general expression. In simple words, I'll explain. Let's say you declared a variable. Okay,
Okay,
you
actually we used for destructors, right?
which destructors. So the same
And
thing.
the
I'm telling what happens when the garbage collector is going to be useful. Then, when if you remember the destructor, I showed you the program execution with the command prompt, right?
yes,
And
yes.
I showed you that it will not
Immediately
guarantee
remove.
whether it might call for 3 or 1 or 2 or whatever. It might not call. So what's
Mm.
happening here? Sometimes it doesn't feel that though you are saying that call me destructor, call me like garbage collector. So it might not call. Just
Mm.
instruction to operating system. Then operating system is taking a decision whether if it requests to call for an object, it's calling for one object. If it requests for 3 objects, it's calling for 3 objects, right? Just giving an operating system, right?
Mm. Mm. Mm.
What basis is taking that decision? Now I'm telling you. If you declare a variable, you assume that you have declared a lot of variables and your program is use complex program. So there are certain variables you are not using and you are leaving them as is and keep on declaring. At certain point of time, your memory might be full, right?
Mm.
So when you further going to declare variable, so though there are many unused variables you are willing to release, but still you have released it, but still in the memory. So when you request for additional memory, what happens? This is that already there are many memory blocks inside the memory which are not being used. So it will call a garbage collector to clean all those things. So release all those things. Then your program is capable of picking the memory slot which is free.
Mm-hmm.
Understood the definition?
Mm.
Now I'll tell you the same definition. It's a principal method of detecting and reclaiming the free nodes. Means garbage collection is a method for detecting and identifying the free nodes.
I understood up to that only.
Okay.
First,
Okay,
usually
that's
do
only
that.
okay. Okay. I'll
Mm.
continue from there. Nodes no longer when I say nodes, it's a memory block. Okay.
Yeah. Mm.
Not specific to the particular program. It's a general statement. Node is a memory block kind of thing. Okay? Nodes
Mm.
no longer in use remain allocated and undetected until all the storage location has been allocated. Means
Okay.
nodes no longer in use. Means memory blocks which are no longer in use
Use.
remain
Okay.
allocated, undetected until all the available storage has been allocated. Means
So this garbage collection, it will detect the all unused memory locations.
exactly that's what the
Okay, and make them into use.
yes, it detects everything. It cleans and make you free memory for your next program.
Okay. Okay.
Okay. So
Mm.
subsequent request for the allocation. So let's
Mm.
say you're doing a program, you're giving a lot of variable requests. So
Mm.
obviously allocation cannot be satisfied until the nodes that has been allocated but no longer in use are recovered.
Mm.
So in one of program you have declared a lot of things, but those are still garbage, not haven't collected garbage, right?
Mm.
So when you ask for additional memory, if it cannot fulfill your request, then it identifies that yeah, let me clean up this memory activity. So then it calls a garbage collector, it clean up everything, makes you satisfy the memory allocation part for your program.
Oh, up to then it won't such identifies that unused memory.
Yes, it won't. So
Okay.
whenever
Okay.
it feels something, then it starts the task.
Okay. Then only it
It
starts.
is available for you to do this task, but it does not keep on checking. It's going to take some intervals, or else it's going to See, like if somebody is not able to get the memory, then it identifies that, yeah, let me do my cleanup activity. It does the activity.
Okay, okay.
Got it. Right.
Understood.
So basically, it has two phases internally. One is called the marking phase, and the other one is called collection phase. That's the
Marking
theory part.
collection.
Nothing you cannot see. Just to give a understanding perspective.
Okay.
Garbage collection is going to garbage collection. What it does, it clean up some memory, right? It does
Hmm.
two phases: marking phase and the collection phase.
Hmm.
So in the first phase, it is going to mark all the notes that are no longer being used.
Hmm.
Second phase, it just clean up all those things. That's all.
Okay, cleanups. Okay.
Yeah. First part, it
Hmm.
identifies
Oh
what are the
yeah.
things which are not being used by anyone.
Okay.
Just
Next.
put a mark. So in the first program, the
Hmm.
next program immediately. The first part is to just identify. So once
Hmm. Hmm.
identification is done successfully, the second part comes into picture. Like what are the things identified? So let me clean up all those things.
Okay.
Yeah. Okay. The
Hmm.
simple times. This is how it takes cleanup activity in the garbage collection.
Okay.
Clear?
Okay. Okay. Oh, so many topics in threads.
So how many topics I have added in thread? I
I
don't know.
mean, before class 19, they also all are a little bit confusing. I'm clear, but those are all a little bit confusing.
Now also confusion.
Not now, but I need to remember, recollect it once again. I need to listen your videos again. I need,
That's why the videos are helpful, right?
yeah, or else it will be very difficult.
Mhm. So how many topics I missed in my
uh,
is that
throws,
yeah, only one line I mentioned.
yeah, multi-threading,
Yeah,
but oh,
but
lot many
it
topics.
was like 3 days IT, right?
Yeah, so many type of threadings.
Yes.
Okay.
So any doubts on the topics of whatever we discussed today?
No.
Then okay, I think we are good for today, and we'll
Yeah.
continue on Monday. Happy
Okay. So, so we covered the whole topics in thread, or still we are any topics remaining in the
We
thread?
covered many of the topics.
Okay. Threads are over.
Oh, threads are over. So from Monday, mostly we'll be starting with the collections.
Collections. Okay. Okay then.
Just remember that Java is a ocean.
Oh yeah, it's a very big ocean. I know that.
Like even like if you tell like the slowly, you can cover for 6 months or 1 year also.
Come on, it's
So
keep
ocean
on
like
going like that if you are
remember
learning.
like if a person is 20 years experience, we can bet that he doesn't know everything.
Oh no, I asked it simply. That's why because these threads are a little bit confusing. That's why I asked you. Still, we are having any topics in threads. That's the reason.
So wasn't I told you right? Any topic if you just talk about what is integer we have to talk about 1 day or 2 days.
Yeah,
If you want to spend like that, we can it continue. But as I said, it's a ocean because of the open source. Lot of plugins comes into picture.
that's
When we
okay.
go for interview, so they'll ask for some new technologies, new
Yeah.
framework because of the open nature. So we need to import all those things. I'll tell you how to
Oh,
import all those external technologies.
okay. Okay.
Yeah, Spring and Hibernate, those things will be covering that. I'll tell you how to use them in your regular
Oh,
Java programs.
okay.
Clear?
Okay. Clear,
Okay,
clear.
Arita. Thank you.
Okay.
Bye. Happy weekend.
Okay. Bye. Thank you. Same to you.